Good morning students. In this video we are going to see Unit 1 Laws of Motion Solved Problems page number 12. Question number 1. Calculate the velocity of a moving body of mass 5 kg whose linear momentum is 2.5 kg ms minus 1. That is, the mass of an object is given as 5 kg and linear momentum is given as 2.5 kg ms minus 1. We have to calculate the velocity of a moving body. So, the given data, mass of a body is 5 kg and then linear momentum 2.5 kg ms minus 1. We have to find out the velocity of a moving body. Formula to find out the velocity of a moving body is linear momentum equal to mass into velocity. From this we have to find out velocity. So, velocity is equal to linear momentum by mass. Solution for this problem, velocity equal to linear momentum by mass. The value for linear momentum is 2.5 kg ms minus 1 and then for mass is 5 kg. Here kg and kg get cancelled. So, the remaining term is 2.5 by 5 ms minus 1. So, to remove the decimal we have to multiply with 10. So, 2.5 into 10 by 5 into 10 ms minus 1. So, 25 by 50 ms minus 1, that is 1 by 2 ms minus 1, 0.5 ms minus 1. So, the velocity of a moving body is 0.5 ms minus 1. So, in the result we have to write the velocity of a moving body is 0.5 ms minus 1. Question number 2. A door is pushed at a point whose distance from the hinges is 90 centimeter. That is, we have to push the door. The distance between the hinges and the door is 90 centimeter. And then the force applied on the door is 40 Newton. We have to calculate the moment of the force about the hinges. So, the given data, distance d is equal to 90 centimeter. We have to convert this centimeter into meter. That is, the moment of the force unit is Newton meter. So, convert the centimeter into meter. So, divided by 100, 90 by 100 is equal to 0.9 meter. Force F is equal to 40 Newton. So, we have to find out the moment of the force. The formula to find out the moment of the force is M is equal to force into distance. So, in the solution, moment of the force into distance, the value for force is 40 Newton and then the distance is 0.9 meter. When we multiply 40 and 0.9 we get 36 Newton meter. So, in the result we have to write moment of force is equal to 36 Newton meter. Question number 3. At what height from the center of the earth the acceleration due to gravity will be 1 by 4th of its value as at the earth. That is, we have to find out the height from the center of the earth. The acceleration value is given as 1 by 4 as the original value of the earth. So, the given data, height from the center of the earth is equal to r dash is equal to r plus h and then acceleration due to gravity g dash is equal to g by 4. We have to find out the height. The formula to find out the height is g is equal to gm by r square. In the solution, g is equal to gm by r square and g dash is equal to gm by r dash squared. So, here we have to divide g and g dash. So, gm by r squared by gm by r dash squared. Here our aim is to find out the r dash value. So, g dash is equal to gm by r dash squared. Now, in this division we have to write it in a multiplication term. So, gm by r squared into r dash squared by gm. Here gm and gm get cancelled. So, g by g dash is equal to r dash squared by r squared. So, g by g dash is equal to r dash by r whole squared. We have to write it in the term whole squared. Now, instead of r dash we have to write it as r plus h. So, r plus h by r whole squared. We have to divide it by r. So, r by r plus h by r whole squared. So, g by g dash is equal to 1 plus h by r whole squared. Now, here instead of g dash we have to substitute the value g by 4. It is given in the data. So, g by 4 is equal to 1 plus h by r whole squared. Now G into, we have to write this division as the reciprocal. So 4 by G is equal to 1 plus H by R whole square. Here G and G get cancelled. So the remaining term is 4 is equal to 1 plus H by R whole square. Now we have to write this 4 in a square. So 2 squared is equal to 1 plus H by R whole square. Why here we have to write it in square means then only it is easy for you to cancel the square on both sides. So here we have to remove the square on both sides. So the value becomes 2 is equal to 1 plus H by R. Now 2 is equal to R into 1, R plus H by R. So 2R is equal to R plus H. Now 2R is equal to R dash. So R dash is equal to 2R. So from the center of the earth, the object is placed at twice the radius of the earth. So from the center of the earth, the object is 2 times that of the radius of the earth. So in the result, we have to write it as height from the center of the earth, R dash is equal to 2R. So 6th Roman answer briefly. If a 5 Newton and a 15 Newton forces are acting opposite to one another. See this diagram. Here F1 and F2 are the two forces acting in opposite direction. We have to find out the resultant force and also the direction of action of the resultant. So force F1 is equal to 5 Newton and force F2 is equal to 15 Newton. So we have to find out the resultant force and the direction of the resultant force. So the formula to find out the resultant force is F2 minus F1. That is F2 is greater than F1. Suppose if F2 is greater than F1, we have to write the formula F2 minus F1. If F1 is greater than F2, then we have to write it as F1 minus F2. Now in this problem, F2 is greater, so we have to write it as F2 minus F1. So resultant force is equal to F2 minus F1, that is 15 Newton minus 5 Newton gives us 10 Newton. So in the result we have to write resultant force is 10 Newton and then the direction, resultant force is directed along the greater force. That is the resultant force always act along the greater force. Thank you students.